Okay, so here's the original problem for 22. 3 inequalities that we want to graph and then find the triangle of their intersections, I think. So in this first inequality, I think the easiest way to graph it is just to find the x and y intercept points. So to find where it crosses through the y, I force x to be 0. If x equals 0, then you just have 8y is less than 74. Dividing by 8 gives you the y-intercept of 9.25. Then to find the x-intercept, I let the opposite one, or y, be 0. Then I just have an equation with x, right? So I solve for x by dividing by negative 19, and I get the x-intercept, negative 3.89. To graph that, I know where it crosses through the x and y. I test 0, 0. In this inequality, if I have x and y both equal to 0, then I have 0 minus 0 is less than 74. That's a true statement, so that's good for that one. I did the same things here and found the x and y intercept to be 4.58, 3.13. Those are both rounded. And the last one, negative 3 2/3 and positive 16.5. For all three of these, when you plug in 0, 0, you get a good point. So, graphing the first equation is a dotted blue line, dotted of course because it is strictly less than, so it does not include the line. And then because 0, 0 is a good point, we're going to shade to include that. So that's all these blue lines in shading. Then my second line was this red line. This was 38y plus 26x. And it's less than or equal to, so it's a solid line. 0, 0 was a good point. It made sense in that inequality, so we shade to include it. Shade this way. And then my third and final line was this orange line that crosses clear up here at plus 16 and then at negative 3 2/3 or 3.67. That solid line shades to include 0 as well, so it shades this way. The intersection of those three graphs, I think, will be these 3 points. So we'll have to do a little bit more algebra to get an address for those 3 points. It looks to me like they're going to be decimals, and this is a really hard problem. So I'll do that one in the next video.